So this is going to be unit in your notes. Oops, up the camera. Is unit 2.1, geometry, vocab, and the overall unit title for this is Unit 2, similarity and congruence. Okay. Now, on the little foldable, okay, which we have right here, you need to put the following titles on the front pages, or the front little tabs, which is, the first one's naming parts of congruent triangles. Okay. Congruent. All right there. Okay. Just want to make sure. Hang on a second. Yes. Okay, good. All right. Just checking something. Segment. Addition. Postulate. Okay. Bisect. And types of angles. Okay, so that's the first one for the first side, all right?
Can you go to show us the top or just zoom out a little bit? Sorry.
Yeah, there you go. I'm going to go back to the top of the other column. All right, the other column is naming parts of a line equal, okay? Notice that these are not the same thing, okay? Angle addition postulate. Midpoint and complementary versus supplementary. Okay.
Is that angle addition postulate?
Yes. Okay. Postulate. Okay. Okay. So we're going to start up here, the very first one.
Can you zoom out and just stay on this for a second?
Yeah, no, I can keep it up. All right, so let's start off with the first one, naming parts of congruent triangles. Okay. Now, we have a triangle over here. It's blank, but we're going to fill it in. We're going to call this angle point A, C, and B. We're going to call this angle 1. Okay. So we name this as triangle ABC with segments AB, BC, and CA. That's how we write the line segments. Okay? we write our angles as follow. There's two ways of doing this. One, given how the angles are labeled, we could have, for angle, we could have angle A, angle 1, or angle lowercase a. Just some options in terms of notation. You can also write an angle as angle BAC. And as I told you guys in class before, always have the letter we want in the middle for that angle, i.e., because it's the vertex. Remember, the middle letter determines the vertex of that angle. You can't, if you write this as CA, if you write this as CBA, you're looking at CBA. That's now your vertex. That's not the same angle as angle 1. Okay, the order of the letters matters. We're going to talk about congruent next. All right, so congruent is the angle of segments of equal measure, which we describe as this symbol, right? Okay, things are congruent. Okay, when I say things, I'm talking about actual physical manifestations of geometry, not numbers. Okay? Very important you understand the difference here. We use equal for numbers, congruent for distances. Now, yes, distances can be quantified, but they can also be shown physically or hypothetically in terms of in paper and pencil, okay? But they're not one and the same. But congruent has a lot more leeway in terms of what it can be applicable to. Equal is more reserved for numbers in mathematical context and will always be there. It will never be used to describe two distances the same, okay? And that's congruent to angle B. XY, segment XY, for example, these are just examples, is congruent to segment DC, and triangle ABC is congruent to triangle XYZ, okay? Just a few examples to point out. 1, segment addition postulate, okay? So, what the heck is this? I get a lot of questions about this one. Shh, a little too much talking, guys. All right? The segment addition postulate says the following. If I have a line segment, such as this one, and I break it into two parts, okay? Call this A, B, and C. And I state the following is here. If a point B lies between A and a point C on a segment, then AB plus BC equals AC. Parts of a whole make a whole, right? That's basically what that's saying. Now, to go one step further, okay, that means that 2x, let's say that I make AB 2x minus 10, and I make BC 30, okay? And I say the whole segment from end to end is 4x, okay? So here's what we know. Or not yet, sorry. So now, using basic algebra, we can actually calculate the values on that line. Any segment, any variable, etc. Okay? So it should look something like this. 2x minus 10, part AB, plus 30 equals 4x. We simplify that. We're going to get 2x plus 20 equals 4x. Simplify, bringing the x's to one side. We get 20 equals 2x, and x equals 4. So now we plug that back in to what we have. 2 times 4 is 8. No, sorry. 2 times 10. I meant that should be 10, not 4. My bad. 10. Okay? Yeah. So, yeah, exactly. So it'd be 40. And now we have everything we need to figure the rest of out. So we know that x equals 10. We know that AB equals 10. And AC equals 40. And there's our answers. All right, so next up is bisect. Okay? Which simply is to cut in half. Okay?
And what does dissect mean?
It's something.
No, he said bisect, not dissect.
Dissect is to take apart.
So dissect is just to take apart.
Yes.
Bisect.
Bisect is to evenly cut in half.
Oh,
An angle, anyway.
sorry, I was just curious.
Yes. No, I understand. It's yeah. Okay. Good question. So to cut in half. Angle bisectors. I'm at the right small here. I apologize. Angle bisector. Okay. A ray that cuts the angle in half. Okay. Whereas a segment bisector a line that cuts a segment in half.
What is that in grains?
Now, what that means, while you're writing that down, okay, is that if I have an angle here and an angle here, okay, and I have, let's label this angle up where I have A, B, let's call this F and C. And actually, I want these angles to be the same, so I'm going to double line them. There we go. Okay. And I make the statement that ray BF, ray is the two letters and then an arrow on top, okay, bisects angle ABC. Okay. That means that angle ABF is congruent to angle FBC. Therefore, three dots in triangular fashion, just an old habit of mine. Okay? You would make the following statement at the bottom. Three dots in a triangular fashion. The measurement of angle ABF is equal, not congruent, to the measurement of angle FBC. So now we're going to talk about the types of angles, okay? There are four types of angles, right? Straight is but all right. We have acute, which is less than 90 degrees. Okay. Okay. Obtuse, which is greater than 90 degrees. Okay. Right, which is equal to 90 degrees. We denote with a little tiny box in the corner. And finally, straight, which is equal to 180. All right. And that makes a line. Okay. All right. Now, the vertical angles, these are really, really powerful. Okay. They are formed by two intersecting lines. Okay. And vertical angles are congruent. And here's why. So if I have these angles here and I label this 1, 3, 2, and 4, 1 and 3 are congruent to each other, and 2 and 4 are congruent to each other. Okay?
What's beneath equal to 180 degrees?
Makes a line.
Makes a line.
Yep. All right. So that means that the statement would be that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Oops. All right. Now, there are, of course, two complementary versus supplementary angles. Okay? I cannot tell you how much people mess this up, so please pay attention here. Two angles, supplementary. Supplementary are two angles that add to form 180 degrees. Okay? There are two types that usually you will get. You will either get a linear pair or a nonlinear pair. Okay? What that means is you'll either have, with an angle coming off of it, so here's 1, there's 2, add together, make 180 degrees, or you will have two angles, such as 120 and 60 degrees, which add also to be 180. All right. Now, the other thing is, complementary on the other hand, okay, are two angles that add together to be 90 degrees. There are two examples of this. Again, one where it's essentially linear and one where it's nonlinear. Typically, we have it where it's like this, right angle. We have some kind of ray that doesn't bisect it, but just intersects it, okay? So, for example, this could be 2 and 1. That could be 45 and 45, which means it's technically an angle bisector. It could also be 20 and 70. It could be 80 and 10. It could be 50 and 40, okay? So make sure you pay attention to the numerical values on that. Or it can be a nonlinear pair, right? Which is an angle such as this that's 60 degrees and an angle that is 30 degrees. All right? Now, I know some of you guys still writing down, so I'll leave that up there, but I want to talk about midpoint next. Midpoint, all right?
What's underneath 1 degrees?
Okay. Now, for the other one, we've got A and we have C, okay? So, for midpoint, right, we have a line segment AC. Midpoint is right smack dab in the center, as it implies. There's B, okay? Now, there's something you need to remember importantly, or remember that's important about midpoints. It can only be used on line segments. Not angles. Okay? So line segment over here, that means that AB, segment AB, is congruent to BC. Therefore, and 3 dots in a triangular fashion is what that means. The numerical values of AB are congruent to the numerical values of BC. Now, for the angle addition postulate, which is the next one here, right? This one. Okay? If I have an angle A, D, and C, so AB, ABD, and DBC, and I say that ABD is 4x and DBC is 3x, okay? And I say that the measurement of angle ABC is equal to 70 degrees, then I can use, again, algebra to figure out what the x value is. I can just say that 4x plus 3x equals 70, 7x equals 70, and therefore x equals 10. Okay? Thus, if x equals 10, the measurement of angle ABD is equal to 40, and the measurement of angle DBC is equal to 30. Which means the following can be said. The measurement of angle ABD plus the measurement of angle CBD equals the measurement of angle ABC. Sorry, I got a little short there on the end. Okay. Now, for this one up here, we've got equals. Okay. Equal symbol. Okay. Equal. Now, that means that numbers are equal. The measurement of angle 1 is equal to the measurement of angle B. Okay? Measurement in degrees. Okay? XY is equal to DC. That's length. Or x equals 2.
In angle O.
All right? The last one talks about naming parts of a line. Okay? For this one, we've got line segment A, B, and C. Whoops, sorry, that should be D. And there's C up here. Okay? With an angle right here. Now, here are the parts that we need to worry about. We need to call the line, rays, points, and angle. Okay? Lines are like AD with a double arrow on top. AB. Okay? Rays are things like BC. BD going and plus BA. Okay? We call those opposite ray formula. All right? Points are things like point A, point B, point C, point D. And finally, angle is CBD or angle DBC. All right. And finally, keep in mind that AB will include D. And when we have two rays that are opposite each other add together, they form a line. So opposite rays form a line. All right, there you go. And that is the complete for the notes for 2.1.